Hello and welcome. Introduction. Now, in my previous videos, I've been using the 7-segment display as a means to display information. And here are the videos that I'm referring to. And I have included the links to these two videos in the description below. Now, the thing is, let's get back to this. You may notice the limitation of the 7-segment display. It can only display limited characters. What do I mean by that? For example, you can display an 8 and 9, and then if you want to display an A, if you're counting in hexadecimal. But notice you can only display a uppercase A. You can't really display a lowercase a. That would be, yeah, I suppose it's possible, but it would not be so perfect. Then you can have a C and a D and an E. Notice with the D, you can't really have an uppercase D because that would look very much like a 0 and so on. So these are the limitations of the 7-segment display. Now, a better choice would be the liquid crystal display, or the LCD module. All right, so in this video, we are taking a closer look at the LCD module and how to program it to display information. So let's take a look at the what they call the pinout of the LCD module, and let me just zoom in and rotate it. All right, so the first pin, or pin 1, is VSS, that's ground. Pin 2 would be VDD, that would be the positive voltage, and then pin 3 is VE, contrast voltage. I think I've seen somewhere before some manufacturer would use VO. All right. Anyway, but pin 3 would be the contrast voltage. That is it will use to control the contrast of the liquid crystal display. And then pin 4 would be register select. Pin 5 is the read/write. Pin 6 would be the enable. Now, it will be advisable just to take notice of these pins here. And then from pin 7, from pin 7 all the way down to pin 14, those would be the data lines. So for example, pin 7 will be data 0, pin 8 is data 1, and so on to 14, where is pin 14 is data 7, so byte, so 8 bits here. And then lastly, pin 15 is the backlight for the anode, and then pin 16 is the backlight cathode. That would be the ground. I think there's a spelling mistake here. That should be LIGHT, backlight. The hardware. Now here is the schematic diagram of the setup. So here is the LCD module, and here is the Arduino Uno, and I've repeated the pinout diagram of the LCD module here. Now, so let's start with VSS. VSS is connected to ground, which is this one here, connected to ground. VDD is taken to connected to VCC. VO, which is actually VE here on the pinout. I remember a few moments ago I said some manufacturer prefer to use VO. That whether you use VE or VO, that is the contrast voltage. And then the register select, or RS, the module is connected to pin 9 of the Arduino Uno. And then the R/ or read-write signal is connected to ground. As I mentioned earlier, because we're only writing to writing to the LCD module, I've connected it to ground permanently for this demonstration. So, and then the E or pin 6, the enable pin, is connected to pin 8 of the Arduino Uno. Now, next come all these data bits here. Now we're using a 4-bit mode, so we are using the data 4, data 5, data 6, data 7, which is on this diagram is DB4. DB4 or data 4 here is connected to pin 4 of the Arduino Uno. Pin 4 is actually on the ATmega 328. That would be port D bit 4. Port D bit 4 of the ATmega 328. Then DB5 is connected to pin 5 of the Arduino Uno, and that would be port D bit 5 on the ATmega 328. And then DB6 is connected to pin 6 on the Arduino Uno, and that would be port D bit 6 on the ATmega 328. And then finally DB7 connected to pin 7 of the Arduino Uno, and that would be port D bit 7 on the ATmega 328 chip. And then finally we have the anode. A backlight anode is connected to a VCC via a 22 ohm resistor. And then the cathode is connected to ground. I think I need to go back to the VO here. I failed to mention that VO or VE is connected to a potentiometer here. That potentiometer is a 100K pot potential, 100K ohm potentiometer. All right, so I missed that one out earlier. So I think we can move on now. So here is the LCD picture of the LCD 1602. Now, the 1602 is actually pin compatible with the, or in fact, identical to the HT4478U LCD module. That is the Hitachi version of this. And the instruction set and the initialization process of both the module are exactly the same. All right. Now, to fully understand how these LCD module work, I strongly recommend that you get a copy of the data sheets. The HT44780 module is by Hitachi. You can download it from this link here. I provided the link in the description. And then you can also download this LCD 1602 from this particular link. I have also included the link in the description. All right, so both this, as I mentioned earlier, both these modules are identical. All right. Now I'm going to extract the from the HD 44780 datasheet some information, and here I have on page 3 of the datasheet the block diagram of the LCD module. All right. So the first thing I would like to highlight is the instruction register, or the IR. To select this register, you need to set RS pin, which is this one here, to 0. That will select IR, the instruction register. To select the data register, DR, you need to set RS to a logic 1. All right. And then I want you to take note of this flag called the BZ flag, or BF. All right. So these 3 registers, IR, DR, and BF. And then the rest of the pins, RS, R/ the read-write signal and enable signal, E, here. All right. Block diagram, and then the data bits, they're all here. All right. So we are interested in DB4 to DB7 because we're operating in 4-bit mode. So these are the pins here, and then right, these are not highlighted on the data sheet. All right. Now, as you would have detected that earlier, I mentioned this uh, module can be operated in 8-bit mode and 4-bit mode. Now, in our case, we are operating in a 4-bit mode. So we're only using this 4 bits here. Now, 4-bit mode, in 4-bit mode, we only need 4 I/O pins. Now, if you operate in an 8-bit mode, you would be requiring 8 I/O pins. Programming the LCD module, the code. All right, so let's start from the beginning. So here, the first 3 lines is they include definition and include directive. You should be familiar with all this, so I'm not going to bother to go into the details of this. Then we come to this part here. Let me just see. Yeah, I put up the schematic diagram here to help me to explain this. So I define something called RS pin and assign a value of 1. And then I define another what they call EN pin, which is enable pin, which is this one here, the E here. The RS is this one here. All right. So RS pin, I defined it as a value of 1. EN pin, I would define a value of 0. So the RS, if you follow this through, is connected to pin 9 of the Arduino Uno. Now, this pin 9 is actually port B bit 1 on the 8 Mega 328. And pin 8 on the Arduino Uno, which is connected to the enable pin on the LCD module. Now, that pin, that is pin 8 on the Arduino Uno, is actually a port B bit 0 on the 8 Mega 328. So I'll be using these values in conjunction with port B later on. And here, following this definition, are the functions that I've defined that are going to be used in the program. Right. So here is the main function of the program or the code. So the first 2 lines should be familiar to most of us here. So this line here will define port B as an output mode. This will define port D as output mode. Now the next 1, 2, 3, 4 lines are basically function. I will come back to this soon. I just want to concentrate on this from the page that I taken from the data sheet, and let me zoom in to this part here. All right, so let me just put up the code that I've just mentioned earlier, the 4 lines of functions from the code, and I've defined these functions according to the data sheet. These 4 what we call instructions are basically the initialization process. You need to initialize the module before you can use it. So the first step is to clear. All right, so I have a clear LCD here. I'll get into the details of this function soon. And then have something called function set. These are the parameters that we have to watch out for. Then something called display control, which is this one here. And then the entry mode is this one here. For each of these function, there are some parameters that we have to look out for. We'll come into that, as I mentioned earlier, as I go through this the code in a few moments. And here are more details of the functions that I've just mentioned, or instruction, or command. Some people call this a command. So here, for example, clear display. These are the setting for the control pins. For example, RS pin has to be 0. The read-write line has to be 0, and then all the 8 data bits have to be in this what they call condition. Basically, this will clear the entire display and set the display data RAM address 0 in the address counter. So this is basically the function of the clear display. It basically clear out the display, and we'll be concentrating on these 8 bits here. We'll come to, again, I'll come to that in a few moments. Then it is entry mode. Like, these are the parameters that we're to look out for. What does it do? Basically, set the cursor, move direction, specify display shift. These operations are performed during data write and read. All right, so that's the entry mode. Then display on-off control, or simply display control. Basically, this set the entire display either on or off, cursor on or off, or you want the blinking cursor. So this command here will do that. And then something called function set. Basically, that's to set the data length, the number of display line, and the font that you want to use for the characters. All right. There are many more, but we won't be touching on them in this video. So much for the command code. And then coming back to this code here, let me concentrate on this part here. And here I put up a diagram of the display. Remember, this LCD module is a 2-line display, which each line can display its maximum of 16 characters. All right. Now, before you can display the characters on each line, you need to, for example, for the first line, look, this location here, the address would be 00 hexa. Now, you need to put in 80 in, you need to use 80 basically to prepare the LCD to display the characters on this line here. All right, and for just a minute, and for this location here, for this line, the second line, the start address, so the start location is 40 hexa, and you need to put in C0 command code first before you can display the characters on this line. So for this one here, let me repeat, you need an 80 hexa. This is a command code to prepare this to display the characters. And then for this line here, this start location here, you need a location 40, you need C0 command code to prepare it to display the rest of the characters. And here, basically, stay once you get to this point, the program will stay here forever. As I mentioned earlier, I define RS pin as a value of 1. And so in LCD command function, I'm using it to set that bit 1 to 0. Basically, that will send a 0 to this. Now, this then will select the instruction register in the module to prepare it to receive the command code. Right, so this line here will basically set the RS pin to 0. That will select the instruction register. Then we need the enable signal. Come to that in a few moments. Then we need a delay of 10 milliseconds. I'll explain the 10 milliseconds in a few moments. And then we send this line of code here to move. Remember, we are operating in a 4-bit mode, so we need to move or transmit the low nibble D4 to D7, and then enable it, and then delay it. All right. Don't worry about the enable and delay part. We'll come to that soon. Right, which is here. Now, I need to just slightly move away from the code for a while. Now, this busy flag, the BF, I have repeated the block diagram here. Which is this one here, right? The top one here is the data register, the instruction register further up, but focus on the busy flag. Now, when the instructions are executed, the busy flag, which is this bit here, this is only one bit, is kept busy, meaning it's set to 1, right, for 10 milliseconds. After that, it is then reset after 10 milliseconds. Now, if it's set to 1, that means when it's busy, you can't write any more commands to the module. So you have to wait till this gets clear to 0. All right, bear that in mind. 10 milliseconds for it to get clear. All right, the last, just to emphasize, the busy state lasts for 10 milliseconds. I've extracted this from the datasheet. Let's come back to this. So, so that's why I have a delay here. All right, for it to make sure that this commands are being executed. So that's why you have a 10 milliseconds. And then the enable. So what is this enable? Let me just come to this part first, and then I get back to the enable. Sorry about that. So this line here will clear the LCD display as mentioned earlier. So you need a 01 hexa, all right, and then you enable it, delay it, all right. So that is the function of this clear LCD function. And then the function set, you need to put 28, basically ignoring this last 2 bits here. This is the RS and the read write. We're not dealing with that here because the RS pin has been set to 0 earlier here. And the read write line is permanently grounded as mentioned in the hardware part. So we don't deal with this, cover this part, and then we have we just need to focus on this. So DL, the parameters here, this has to be set to 1, this bit here, all right, by default. Then DL, the number of data lines, display line is 0, and let me just put it up here, N is 0 because it's one line display, and then 0 for 5x8 font that we are using. All right, so 28, and then enable again, and then this a delay of 10 milliseconds. Now, come to the enable pin. I keep mentioning about this enable, and I keep saying that I will explain it. Now, so the enable pin, or the ENP, what we call directive, sends data to the data pins. All right, so you need this. Under normal condition, the enable pin is set to 0. To send data to the data pins, a high to low pulse is sent for a few milliseconds. After this, the enable pin is then reset to 0. And from the datasheet, the width of the pulse should be about 230 nanoseconds. All right, and that here is the timing diagram. You have your RS, which we have set to 0 because we're issuing command, and then in our case, the read write line we're permanently grounded. And these are the data that we want to send. Now, the enable pulse, which is this one here, the width, this from here, this point to this point here, that should be 230 nanoseconds. All right. So, and here it is, 230 nanoseconds. Translate that to microseconds. That is 0.23 of a microsecond. So that is the width here. This part here will send it we'll send it to a 1, and then we'll set it back to a 0 here with these two instructions. But the width, all right, should be 0.23 of a microsecond. Now, coming back to this part here, the display control, I hope that's not too confusing, because I find this LCD module is quite involved. All right, so you just bear with me, and you need to go over the data sheet and by yourself and go through this, and I promise you'll get hold of it. So display control. So we need to issue the command 0E. What does it do? Basically, we are setting the display on and cursor on, and we are not blinking the cursor. If you want, you wish, then you can set this to 1. Then you will have a blinking cursor. But in this video, we're setting this to 0. And this bit here is by default a 1, so we have to include that. So that will be 0E. So you need to put 0E, enable it, delay it, make sure the whole thing is carried out. So that takes care of the display control. Then the entry mode. The entry mode, by default, this bit is set to 1. I/D, basically, that says I want to increment the cursor by 1. All right, so we'll move the cursor, and then S is set to a 0. So the whole thing is 6, 06 hexa, and enable, and then delay. All right, so remember, the enable here will send the command to the data pins. Then you have to have a delay of 10 milliseconds to let it complete the operation. If not, the busy flag will be still set to a 1, and you can't issue any command until the busy flag is reset to a 0. So you need this 10 milliseconds for it to complete the operation. And the enable here, we have explained it earlier. Now we come to the LCD data function. Basically, this line here, we're using that RS pin to select the data register now, because we want to transmit data. So far, we have been dealing with commands, right? We have been dealing with the initialization process. Now we come to actually displaying the data. So we need to switch to the data register. So RS equals to 1, and then you transmit the high nibble and low nibble. Again, the familiar enable this delay that is required for this to complete the operation. And then finally, LCD print. This function here basically take off the text that you want to display and display it to the LCD module. All right, so that's it. I hope it's not too complicated. You just need to go over it slowly later on after the video. You need to perhaps replay the video several times and look at it and try it out and experiment with it. All right. The code demonstration. Okay, so I've uploaded the code onto the AdMail Studio 7. I'm just going to show you the code. It is exactly the way we have discussed in the discussion that we had earlier. So what I need to do is to take this out. Yeah, all right, take this out. Let me just save it. All right, so and the camera, right, at the moment is blank. The LCD here is blank. This is my LCD, and it's connected to the Arduino Uno. Let me just pan it across to let you see. Uh, this is the potentiometer. They will adjust the contrast, and the Arduino Uno is right at the back. All right. So yeah, let me just adjust the camera. Okay, looks good. All right, so we'll come back to the camera later on. So basically, the code is here. It's exactly the way we have discussed earlier. So I'm not going to bother going through that again with you. What I'm interested here now is to uh, build the thing, or rather clean, rebuild it, and I'll now upload it to the Arduino Uno. Right? So it's blank at the moment because I haven't insert any text here. All right, so what we're going to do is try this. So I'm going to type this is line 1. Oops, wrong spelling. And so here what I'm going to do is this is line 2. Let's get this right. Put a full stop in. All right. Okay, so let me just rebuild the thing again. Right. Okay. So now I'm going to do is I'm going to upload. Oh, can you see my mistake? I forgot the quotes missing, the brackets missing. All right. Oh no. What I've done? Oh, sorry. All right. So this look good. Save it. Rebuild it. I think we should be good for this. All right. So let me upload it. All right. So where we are, we have this is line 1, this is line 2. So that's up. So let me just change the text here. I'm going to put edit systems, and I'm going to put education. That's the name of my channel. All right, so I'm not going to bother with the full stop as this is not a sentence. So rebuild. Right. Okay, I'm going to upload it this time. All right, so there we are. So we have embedded education, embedded systems education. Now, I would encourage you to kind of experiment with this. For example, the display control. We have the display on, the cursor on, and to get a blinking cursor, we need to have F, which is 4 ones. If you recall, if you go back to the early explanation, you'll see that the last bit, the least significant bit, has to be set to a 1 for a blinking cursor. So go check the datasheet out and experiment with together with the datasheet and play around with it. That would help you to understand the LCD module a bit more. So let me rebuild this thing, and then we upload it. Right, so can you see now the blinking cursor at the end here? All right, so yeah, so I highly recommend that you go through the code yourself and to play around with it. I'm sure you will learn a lot more than just watching my video. And I hope, by the way, I hope it's been useful. All right, so so much for the demonstration. Okay, that's it for this video. I hope you found the whole video useful. Uh, I strongly encourage you to experiment with the code. There's no other way of learning about this. And get yourself the datasheet. I've included the link to download the datasheet in the description. So have fun with it. And thank you for watching and see you in the next video. All right, bye.